test?
No, it's for
$5
this
million.
part. This part of the test.
I think just 2 actually.
I'm not gonna do it. I'll just bring
Out
in
of
2
30.
boxes of tissues.
It won't hurt
We're
us
good.
that bad.
Yeah. I get the myth, but
That's right.
average is off.
Yeah, you'll be fine.
So I'll
Why
get
Kleenex?
100 anyways.
Oh yeah, extra credit if you bring in some Kleenex.
Well, you know I need that.
Okay,
What's
so
the max?
number
The
1.
max is 3.
Number 1 for the worksheet. Of this entire worksheet, I think number 1, about halfway through, should be intelligible up to that point. So, until we get to about halfway through number 1,
I tried it.
hopefully this jogs a memory from what we did in class. After that, things get hairy very quickly. And the reason for that, and the reason I didn't do just more that are just like what we did in class, is these examples that you did in class for your notes and these ones on your homework, I took directly off of past AP tests. Because I want to make sure this is geared exactly towards that for you guys. Yeah. Okay. So, number 1, the brakes are applied to a car originally moving at a velocity v original with a brake force of negative kV. So, negative kV is your force.
Yeah.
So, like if we start with this, F equals ma, our force is going to be negative kV. So then it says solve for the car's velocity v at any time t. Friction is negligible. So force is negative kV. It doesn't say anything about any other forces we need to take into account. And of course, what do we do with A?
You change to velocity.
Yep. A is the same thing as the derivative of velocity with respect to time. So we go ahead and we make that change. And then we get moving on this.
You move the M.
Yep, we're going to move the M and we're going to move the V. Did it go well? Yep. Thank you very much. That went quick. Nice job.
Yep.
That's
okay.
That's a lot of paper. It's one of the tests.
Yeah, these are all graded already.
Nice. Holy moly. That's probably faster than I would have done them. Nice job. All right. So we're going to separate and we're going to make the M and the T's be on the same side. And we're going to have the V's on the same side. If you've got the same letter, you want those letters to share the same side. So when we move the V's together, we're going to end up with this. And then the other side's going to be like this. Make sure you can see the math on how we get from here to here. If you have questions, let me know.
Okay. Okay, that makes sense.
How did we get there though?
Just kind of wrote it backwards.
My head's kind of thinking backwards.
This is a backwards thinking class.
It's not like a 37.
No, is it supposed to be velocity over dv?
Degrees.
What's that?
Is this supposed to be velocity over dv?
Yes.
No, but
I mean,
the dv has to be in like the numerator. This cannot be in the denominator. These have to be straight.
But why v is well?
Because in order
Let me
to
see
get
my notes.
this v and that v on the same side, we would have to divide both sides by the dv. Or, if we wanted to go the other way, which we have to do, we have to divide both sides by this v. So dv is like remaining over here. We're going to divide both sides by v. That's why it's down there.
Very confusing.
Yeah.
Yes.
The main thing you got to remember when you're doing this kinds of math is you can treat these two things as just like regular variables. And these two things have to be not in the denominator. I don't know what you would call that. They have to be just like in like a main spot. Further questions on how we got from here to here? Okay. So, yeah, just math. Then the next step is, well, we got to do integrals.
Isn't it weird that math now has no numbers in it?
Yeah. And the numbers it does have are often imaginary.
I don't like that.
Not in this class, but...
The class is harder than my calculus
Could you imagine telling
Well,
me-
this is your calculus class on super steroids.
could you imagine
You'll get to
telling
this
me
stuff
the
probably near the end of the
numbers?
school year.
Did you know they were
Yeah,
numbers?
it's-
No, you're like,
For
no,
us,
you're
it's
just
like
not
within
looking.
a
It's
month.
like,
Yeah.
no, they're real, they're imaginary, and it's torture.
Okay, so we're starting with an original velocity here. And we end with a final velocity. So because it gives us those limits, we got to put limits on our integral.
This last time is going to be interesting.
Over here, we have to put time on it because we're taking it with respect to time. And if we have limits over here, we got to have limits over there. And now we integrate.
What?
I forget how the thing on the integral goes. Do you plug in the bottom and then the top, or do you plug in the top and the bottom?
We do top first, and then we subtract, and then we do the bottom.
Oh, okay. Because I'm like, I know it does top.
So then for this one, integral of 1 over v, anybody remember what that is?
Oh, I like your green shoes.
Thank you.
Match your shirt.
Sure does.
Did you tell a dad joke? Can you?
Yeah.
Wait. Let's integrate and then let's joke.
Okay.
No, that joke first.
Well, no, let's finish this and we'll do the
finish
joke.
it first.
It'll be our cure after
Yes.
this mess.
So, all right. Integral of 1 over v is going to be equal to the natural log of v.
We have natural law?
Oh wait, that makes sense.
Wait, what?
That makes sense.
Yeah.
That makes
Wait,
sense.
no, that does not make any sense.
Because
No, where's the
Is
natural
that
law?
wanted to add a little bit
Is
of
that one
joy
of
to
the
your day.
special rules that we wrote down in that list of like?
Yeah, it's like when you take the derivative of natural log, you get 1 over x. So when you take the integral of 1 over x, you get natural log. This was one of those rules that I had you write down that one.
What's
day.
the natural law coming from? Where did it
It's
come
a
from?
rule.
It's just something
Yes.
you have to know.
It's on that sheet that you.
I have
That we get to use on the test,
You can
right?
use
Yeah,
that
you can
sheet.
use that sheet on the test.
The rules.
It was
Your
it was a
notes.
giant box of like integral rules, and I had you write them all down.
Back?
Of equations,
Well,
yeah.
That's a formula sheet. That's different. Yeah.
Oh, you took notes on it.
Yeah. We had to write them all down.
What is that question?
What's this?
Nope.
Natural law.
So when I take the integral of this over here, note that neither of these letters are the letter t. And so it's like they're like constants then. So a t is going to magically appear.
So
Oh, because you integrate. Haha. never
Yep.
mind.
That's evaluated from 0 to t.
That's not funny.
why don't you put a T in the bottom? Will it cancel out?
Down here?
No,
No,
like
in
an
the
M.
Down here?
Yeah.
You just don't. Like
Wait, we can take the derivatives out of that function.
Like
Why
if-
stay the same?
if you take the integral of 4 and you take it with respect to x, the answer is going to be 4x.
Yes, but what if
Yeah,
you did
but what's that to do with
thirds?
the function over there?
Over here?
Yeah.
Because neither of these are the letter t, neither of them are what you're taking the integral with respect
So
to,
it's a constant.
so it's a constant. Yep.
Got it.
And so you multiply that constant by whatever letter you're taking the integral with respect to.
Oh boy, oh boy, oh boy.
So could you do the
I still
quantity
don't
of
get the
negative
M part.
k over
Okay,
m
now I get it.
times t?
Okay,
and that
so-
would be the same
Now I
thing.
Do you
get it.
Yes.
understand?
So
I
that's
got
why.
the top out. I just
Okay, so you're multiplying by x, right?
I don't know.
So on the bottom one, you're just multiplying by t. So when you multiply, it's just numerator times numerator over denominator times denominator. So t is t over 1. So then it's kt over, haha, Katie, over 1m.
Further questions on this insanity?
Okay, so you
Yeah,
got your-
a lot. Not just a little.
Okay. Well, if we got a specific one, let me know. So if we're going to do this then and actually put these values in here, you know, if we plug in v for v here and then we subtract v original, it's, you know, natural log of v minus natural log of v original equals, and then if I plug in the t for t here, that's just negative kt over m. And if you plug in 0, it all goes away, so we're just left with this right now.
We're done, right?
Well, this is
Halfway.
Where it gets
let me tell you something.
You just moved the original velocity, the net log of original velocity to the other side. And
No,
then you
because we gotta
the natural.
You have to
Then
solve
you use
for
the
V,
natural log
right?
thing to solve for v.
you gotta pull the v out though, you
Yeah.
know.
So that's
Yeah.
why I say move the natural log to the v over to that side.
But you can't just like pull this out of a natural log function.
No, I'm talking about the original velocity. Move that to the right side.
He's saying add the natural log of original velocity to the other side.
Move this. Oh, put this over
Yes.
here.
Yeah.
Yes.
Yeah, you can do that, and that's fine.
Then,
But you can't just pull the v out of the natural log if that's left on the left.
no, we know natural log is something into the.
Yeah, and that's where it gets really hairy. So what I was going to say is, if I had this problem on an AP test, I was fortunate enough to get this far, I would probably just call it right here. Because honestly, for those math problems that they would have on there, most of the work, like let's say it's worth 10 points. Up to about here, well, up to here is probably 8 or 9 of those 10 points. Going beyond this would be just pennies. Most of the points are up here. If you set it up right, they don't have a lot of points for the actual mathematical part. The physics is just setting it up, realizing that your acceleration is dv over dt. Heck, this is probably half the points, just right here. So if you're okay
5
up,
points right there.
it could be. It could be. Setting up these problems is more important for physics
It's not.
than the actual math part of going through and solving them in terms of point distribution. Now, all that being said,
We're gonna do
Let's
it
not do
anyway.
let's just finish it up here.
What?
So,
Oh, so are we solving?
yeah,
Yes.
we got to solve for v. So what you would do then, and just try not to worry too much when you see this.
We're all
But-
gonna just start crying.
You got to do a lot of math to get to a
Can
solution.
I go to the bathroom first?
Nope. Natural log of v minus v original is
I'll come back.
equal to that. So that's equal to negative kt over m.
Oh.
Does that look familiar at all?
Yeah.
That's not bad.
So now we're, just a little bit more math to finish this off.
That's math.
And in order to get rid of this natural log, anybody know what we got to do?
That's
You
E
to the.
Very good. So we got to basically shift these up into an exponent of the letter e. So e to the natural log v over v original is equal to e to the negative kt over m. So e to the that is just going to become v over v original. And the e is going to remain over here because there's no natural log to disappear. So finally then, if you want to solve for that v,
times VO.
yeah,
Yeah.
Mr. Hathaway,
We
looking
did
kinda
it all
sus
by
right now.
ourselves, guys.
Look, I was right.
what was that, Placido?
You're looking kind of sus right now.
Sauced?
Sus.
Suspicious.
Oh, yeah. That's what I do. I thought you
How
said
is that
sauced.
better?
No.
How is that better?
I think sauced means
That's
drunk.
way better because then you just solve for velocity.
Yeah. Wow, so you guys like the end.
Yeah.
I would think this is a little bit easier for me.
So much
See,
easier
but
than
see,
setting
but
up.
Hell
that
no.
math makes sense.
If you give me
Okay.
the equation, I have a
Yeah,
small
I-
chance of actually being able to do it.
All right.
If you give me that, I'd easy.
Any
now we're talking about second one.
any final questions on this?
Why?
If you're gonna take anything away from this, I would really, really, really like it if you can get to this point. That would make my day.
I'm close.
So focus your effort in all these ones that we practice on getting this far.
I can get to the second line.
This line?
See, I didn't even get to the first
I
one.
wrote down stuff like
so-
DT, but never. If I think about it and then
really hard and like get to the third line.
That's all I did.
And then after the third line, that's about it.
Yeah.
That's all I have.
Well, this is
I got to velocity equals original velocity minus kv.
When I solved this by myself, I got -1.
okay.
And that didn't have anything to do with the equation.
Yeah.
Very
Yeah.
nice, Jaden.
You know, you were somewhere.
You did something.
And you know what? I am just... There's enough to do in AP Physics on that test for them to have to add junk like this. I'm so tired of these differential equation problems because they're mostly math. And so I'm hoping that they're starting to phase them out. It's been a good 3-4 years since I've seen one on there. But I do have to make sure that you at least have seen them before. But, again, if you get up to this point, that's well over half the points. Well over half the points. Solving it is secondary.
Emergency meeting. Mr. Hathaway's the imposter.
Oh. Like you mean who took it last year?
So, I was thinking about my wedding the other day,
Oh yeah.
Oh.
and it was a beautiful ceremony. In fact, it was so beautiful that even the cake was tiered.
That was good.
How do I use the vent like Mr. Hathaway?
That was good.
Mr. Hathaway voted on.
How do I use the vent
Mr.
like
Hathaway has my sense of humor.
Love it. That like Mr. Hathaway.
This is so much different from
Love
second hour.
Mr. Hathaway. And you should go
Second hour,
into
we
the
all kind
basement
of just
and
sat
then
there
come
and
up the other
went,
way.
haha.
Yeah.
Put me in any of your class. Just call me the first 5 minutes while you tell the joke. I'll have this
Just to
whole
get
class
it.
laughing just by laughing.
I should make a laugh track of just you. That's what I want to do.
Yeah.
That's the laugh
You
right
already
there.
have it.
I can't. It's quiet on there.
Just getting really, really close to the microphone.
All right. So we got to look at number 2 briefly. This one's actually easier, except the thing is, in order to do number 2, there's a little known fact that you need to be aware of. And what that is, and you're going to learn this over and over again when you get to integrals in your calculus courses if you're in them, is that when you take an integral, like integral of x squared, the answer is technically not just...
It's the constant. It's the constant.
How the heck did you know that already?
What do you think she does in her
Did
free
you
time?
take calculus already?
No, they mentioned something about it today, and I was like, wait, we didn't learn that yet. And
Man, you should be the one up here. And you haven't even been here for like a week.
we haven't.
So
That's the truth here.
the answer is not technically just this. You have to add a constant. Because, if you think about it, if you take the derivative of this, yeah, you'll get x squared, but you'd also get x squared if you took the derivative of 1/3 x cubed plus 4.
Yeah.
So this 4 is kind of like...
Because when they
Your
had
constant.
mentioned it, I was like, that makes sense.
Plus
but-
0. That's not
And here's me. I have no clue what's.
Sometimes.
Okay.
The main thing is that if you take an integral, you're supposed to add the letter c after it when you're done.
Well, if they haven't.
No, you're supposed to add it all the time.
I have it plus 0.
Because you'll never...
Letter C?
Yeah, because you'll never... You'd never know if there was a constant there before, before that integral was taken.
So
So,
it's a little thing we have to.
yeah.
Okay.
So that's what you need to know in order to do problem number 2.
It's magic.
I'm pretty not sure.
All right. So number 2, this should be a little bit less
Last.
more painless.
What's the real?
What's
What's
It's
the
integral
so
to the integral?
variable, more painless.
Can tomorrow be in
There's
Among
still
Us?
pain present, but it's not as sufficient.
Everyone needs to be here tomorrow. We're gonna play Among Us with
Not
Mr. Hathaway instead of this.
I've got a little activity that we got to do tomorrow, but hey, if we can get through it, then we can do whatever that is.
We only have 15 minutes, guys.
I wonder what people 10 years in the future are going to think of the game Among Us. Was it a big hit? Or was it just a flash in the pan?
It was a big hit.
That's too
I wonder. Okay.
I'm gonna read off some.
We have way too much fun with the recording.
You should have seen what I was doing in physics. I had my little Sonic the Hedgehog as they were working. It was a review day, and I was just peeking them from around the corner. It was awesome.
It was entertaining to watch. But like you're
see
like
the hand puppet?
no. I didn't pay that close attention to it.
Okay, let's see.
I was in tears because he was.
Jada, you know
But
what?
from worksheet
When I
7, you're
watched
like,
the version
don't ask
first,
why.
I
And
was
literally,
like,
as you said,
oh,
don't ask why, I was like, why? And then you said it, and I was like, oh.
I watched last Friday's class because I missed it, and I just heard you complaining the entire time in the back.
You're wrong.
You're not wrong.
Nobody's putting money on that. Good job.
Okay, let's focus. Let's get through this. If we get through this, and we can get through the beginning of what I'm going to have you do tomorrow, we might have some extra time at the end of class that we can do whatever that thing is. So,
Whatever that thing is.
I'll assume among us doesn't mean do drugs. So, integral of AT. Because, remember, it says at the beginning here, the integral of acceleration is equal to velocity. Just like if you would take the derivative of velocity, you get acceleration. So, somehow, we have to use this in order to come up with the familiar expressions for position and acceleration and velocity that we're sort of used to. So, this is where the story begins. If I take the integral of acceleration with respect to time, that's the same thing as just writing integral of a dt. Now, is there a t in here?
Kind of.
Where did the D
Wait,
go?
what?
Oh,
What's
it's
that?
D.
No, not really.
Why would you
No,
do
there's
that?
not a t, there's just the letter a. So, when we take the integral of something that doesn't have that letter in
You
there,
Put it in there.
we just put it in there. So the answer would be AT plus
C.
our constant. What do you suppose our constant would be if we're ultimately solving for velocity?
It's whatever initial time.
Yes. So velocity is equal to AT plus original velocity. Does that look a little familiar? V equals V original plus AT.
Probably.
Yes.
Where did that you were?
All
That was
has to do
probably the most used velocity equation we did last year. And in the equation, usually this comes in first.
Where did the T go?
What T?
When you have velocity of T, that doesn't equal velocity.
Oh, velocity with respect to time. Yeah, so that's just you can leave the T out if you want in that case.
Wait,
Why do we take
Because it's with
Why do you
respect to
get it?
time, so if you've got the time here, it's the same thing.
why
I
do you
can
take
leave it
the
in.
derivative of
Oh, yeah.
place?
You can leave it in if you want.
Wait, so
I just gotta say this
What-
one time
what
we've
takes
been like,
the
what if you're
VT
just messing with
out?
us? And today we're like, oh, you can just add this and throw that out just cause. Like, what?
Questions on how I went?
Yes.
Okay. I can do it again.
No!
So, any questions on this?
No,
Up here.
not that.
Okay,
The
that's
second
stated
part.
in the
Here?
problem, so I get
Yeah.
that.
Okay.
Where'd you
So,
get
Why
this
are you
from?
taking the derivative with respect to t of that?
because it says in the problem, it says recall integral of a is equal to velocity.
That's
So-
the original equation. So why are you taking the derivative of time or derivative of t after that?
Because if our expression of velocity is with respect to time, then our integral has to be with respect to that too.
If there is a T with the wing, there gotta be.
Oh wait, it's not.
Yeah.
It's not derivative. It's just respect to.
Yeah.
Okay.
No.
It's not derivative.
I don't get
It's not derivative. It's not derivative.
Where'd I lose you, Potter?
I'm nowhere.
So.
I love this. We're vibing.
I'm probably not good with English. I have to read. I would go
acceleration
back and
with
read
respect
learn.
to time is.
Just English.
There must be a
in general.
miscommunication.
So see. Oh, okay.
Can I have
Okay,
two
you
notes?
guys stop talking. I
I get the
know.
first two
I
parts.
don't-
Okay.
Now I get where you got the third from. Okay.
Why do you throw away the with respect to time?
You don't have to. I could leave this in. I just threw it out because this is closer to the equation we used last year. But you can leave that in.
But like when you take the integral of acceleration with respect to time,
Velocity go into it.
Does this guy go to the derivative, or does it just like kind of do what you did
Well,
with the velocity?
Okay.
Because it's with respect to time here, that means that like when you take the integral, that's just what you're taking it with respect to.
Gotcha.
Wait,
Kind of,
wait,
but okay, gotcha.
Can you write down the symbols for derivative versus the symbols for integrals quick?
Sure. Integral is this. Derivative is, if you're taking it with respect to time, it would be this.
So it's d over d of something.
Yeah.
Okay. Kind of.
So unless it's just the d of.
So why can't you take
I can
parentheses
use just
t
the-
of to dt?
You don't
Yes.
have to take it out. You can leave that in if you want.
Oh.
I took it out because if I take it out, it looks a lot closer to the equation we used a lot last year. V equals V original plus AT.
So you can leave actually leave the t
Yeah.
inside, so it doesn't matter.
Right. Yep. Okay.
I have to tell you about calculator.
Oh no.
Where did you get that VO coming from?
Well, this is because when you
So
take
that's
the,
the see you later.
yeah, and because
Got it.
we're solving for velocity, that constant is just going to be whatever velocity we started with.
Oh, now I get it. Now I get it.
What are we
Am I gonna
getting?
be able to repeat it? No, but do I get this one? Yeah.
I like
Ooh,
how
that's a perfect way to
That's the
describe
key.
how I
So
feel in this
instead
class.
of
It
writing
makes perfect sense when he does it, and then I want to do it, and then it's like, oh.
What
Let me
if
do
it's
this
the
for
first
And
fun.
when we were in class, and I was like,
So-
yeah, this is fine. And then I got the worksheet, and I'm like,
So can I write
well,
like
F
C
equals
plus
to
VO?
KB.
I got the worksheet this morning.
I mean, that wouldn't be wrong, but because you're solving for velocity, then your constant would have something to do with what you're solving
Okay.
for. So, okay. So let's take this one step further. So,
What do you mean?
More?
if we took the integral of acceleration to get velocity, what do you suppose is going to turn into if we take the integral of velocity?
Acceleration.
No.
Distance. Time.
Distance, yeah.
Yeah, for sure.
And that's listed on your sheet too.
I don't know.
Because we went.
The double integral of acceleration is position.
That's actually a thing. Double integral.
Yeah.
We did like
So-
double derivatives, right?
But
Yeah, we've done
okay.
double derivatives.
So a double integral of acceleration would be a single of velocity, right? Or are they
You did?
different?
Say that again?
The double acceleration integral is the same as a single velocity.
Yes.
Yes.
Therefore,
They're both.
we want to solve for position, and we start here just kind of like how we started over there, since you guys are kind of used to that.
That's the point.
You need
Can
a
you
buddy.
leave the like xt is whatever thing?
All right, so these are the same, just we've got an extra integral there. Now I'm going to get rid of one of those integrals because we already did that integral. So we're left with one integral of at plus vo.
So it's use x equals, right? Yeah.
Yep, so now this is position that we're solving for. X's would be
Wait,
over
why
here.
Why are you using velocity again? You're not solving for velocity.
Well, because, you mean this velocity?
Yeah.
This is because this was the result of the first integral that we took. When we took the first integral of acceleration, we ended here. And so if we're taking the double integral of acceleration,
Wait,
and I already took it once,
this connection between two equations?
yeah, in the same way that if you take a derivative, the double derivative is just taking the derivative once and then doing it again. For integrals,
Oh.
if you take the integral twice, you just take the integral of your answer from before. So you're just following that step an extra one. So, because we did our first integral over here, we just got to do it again in order to get position. So, what's what's that?
How did you go? I still don't understand how you went from the second line to the third line in that.
Here to here?
Yeah.
So,
Can I get where the AT comes from? How does VO get in there?
because this whole expression
This works, right?
So this
comes
will
from
be-
here.
This will be one.
Why are we plugging it in?
Because this was the first integral of acceleration.
Two.
So
We already did this integral once. So to get the double integral, we just got to do it again.
Right?
Let's just be patient.
So is this gonna
Okay.
be 1/2
So
parentheses
maybe-
AT plus VO
I agree
squared
with
times
most of it.
T?
One thing
You're almost there.
'Cause I was
You got
trying to
it
figure
pretty
out
much
the,
right.
Acceleration times
things
squared
put in
plus
but I don't know if there is one.
So the integral of AT.
Wait, you have to, haha.
What do we got to do with the exponent here?
Bring it to 2.
Yep, turns into 2. So the 1/2 is going to come out in front. So we'll have 1/2 AT squared plus,
VOT.
yep, plus
VO.
XO.
plus the original position.
X's.
Is this looking a little familiar?
I did it.
This is that long,
That was the
ugly
long
position
one.
equation that we had to deal with.
Yeah, it
They
was.
seem so much more friendly then. They were so
I like
chill.
it when you just gave us the
Yeah.
equations.
If it's not familiar, we usually started that equation with XO. XO plus VOT plus
Why
1/2
don't you
AT
solve
squared.
the parentheses first? Like you move the whole thing or something.
Well, just because you got to put it in parentheses to know the
This is
entire
where
thing
math
is with
makes
respect to
sense.
It's
dt.
all making sense.
Can't relate.
If you have an integral that you're taking that's more than one spot, you gotta
Gotcha.
If you have
use a parentheses.
The derivative, it's not the derivative, it's the integral. So the integral of your increasing. So it's
Okay, this makes sense.
I think
Good.
this is the least
So
I have
so
ever
imagine
reserved
this
a star.
as t to
I like it. That's fine.
It was a tough assignment.
I started it first hour and I kind of looked and I was like,